Hi everyone, my name is Carlos Lachos.
I'm Josh Ramirez.
And I'm Emily Albert.
We are working on the power distribution for the Eagle Mobile Robotic Carrier project, which is sponsored by Airborne Way. This project was implemented by Roger Gibson and his colleagues at Airborne Way, and it envisions to solve the traffic congestion experienced in major cities, as well as the reduction of carbon footprint, advancement in human travel, and a secure and futuristic way of transportation. This new transportation project planned to first be implemented in Stamford, Connecticut, and is being worked with the collaboration of the mechanical engineering team and advisors.
Our solution for this problem is that we designed a power distribution system which allows us to send power to the major components of the Eagle system, such as the drive motors, the elevator motors and system, and a cabin load center. And we'll collaborate with a mechanical engineering team who's working on the elevator. And these are some of our power requirements for the system.
For our system, we have a systems design model that will eventually show an overall layout of how we want the power distribution system to work. We initially have a transmission lines with bringing power from we believe will be EverSource, or whatever current electrical carrier is providing power throughout the area, and which with the Eagle Mobile Robotic Carrier will be designed. That will go through the transconnector, which is last year's work, which could take power from the cable lines and then use it to power the switchboard. This will go through to the electrical control panel, which will allow us to control the elevator itself, the load center, which will allow it to power the various components inside the cabin, as well as the elevation and drive motors, which are responsible for moving the cabin vertically and horizontally, respectively. Overall, for our system, since it's much too big for us to implement feasibly in person, we opted for more of a simulation in which you can see for our power distribution system, we used a three-phase power distribution system, as the three-phase signal is far more efficient and as well as economical to implement. As a result of this, we can see that each of the branches implements a three-phase step-down transformer, which steps down the voltage to a manageable level, and each go into a breaker, which would allow someone to control the voltage and cut it off in case of any issues coming up. And as you can see, we have some example simulation below, where you can see the current and the voltage going into the cabin load center, which hits around 7,000 requirement that we were needing for power.
And on the right side, we have a representation of a subsection of the overall distribution system, which is the load center. So this shows all the required loads, such as the lighting, the climate control, and outlets that will be in the cabin itself.
Here we have the regenerative braking. As we planned, since we completed the power distribution system, we wanted to make sure to keep making the project more feasible. To that end, we have been doing research and finding out ways to make it more energy efficient, and allow for more of the systems such as Wi-Fi and electrical component location to be more useful. For the regenerative braking part, where kinetic energy is transferred and used for energy conservation, and then used again to allow us to power the Eagle Mobile Robotic Carrier itself, we chose the R6 line regen from KEB, which is well known and has high reviews, and will allow us to replace the braking resistor and improve our energy consumption by leaps and bounds.
Here the picture showcases better what is the plan for this project. The transconnector will receive power from the power lines, which will be directed with the help of the tether to the Eagle. In the Eagle, will hold the three-phase distribution panels, as well as the motors for elevation and driving the cabin. The dimensions for the Eagle are still to be determined by the sponsor once this project is concluded.
Another important requirement is that all the cabins will have Wi-Fi available for passengers to connect their phones and laptops to. So this will use a system of wireless access points and Ethernet network. And each cabin will have one of these wireless access points. So this is a useful system for covering a large area of users, such as on public transportation. So it'll be similar to what's used on passenger trains.
That was our presentation, and thank you for listening.